BCAOL that info group yours. All of you should write your enrollment number and name in the chat box for attendance.
Yes, ma'am.
And my screen is shareable.
Yes, ma'am.
Ma'am.
So, have you received? All of you have received the email regarding the change of your problems. Any problems are there? So there is a Google form. Everybody has received that.
Yes, ma'am.
No, ma'am.
So if anybody who's not received it, your registered email ID, it will be coming on if you have registered in your BCA. Maybe look in, if you have not received, just look in the spam, if it has gone to the spam, right?
Yes, ma'am.
Okay. Yes.
It is
Ma'am,
in the
I didn't
spam
get
folder.
that
It is in
email.
the spam folder. In promotions. it is
Those
in
who have not got it, first and foremost, if you will get it in your registered email ID when you have taken admission, that email ID which you have registered with, right? Second of thing is, if you have not got in your inbox, just check your spam box whether you have got it or not. Sometimes it goes
Or
into the
promotion.
junk or spam, right?
Ma'am,
So
there is nothing
yeah.
in the spam, ma'am.
Then is it the same email ID you have registered when you have taken admission?
Yes, ma'am.
Please check once in promotion section also.
Okay.
So today we have to do the block 2, unit 1, that is software. So we had already studied what are softwares.
Yes.
What are softwares then?
Software is a
application
applications.
for particular work.
It is a set of instructions.
Yes, it is a software is a set of programs, you can say, right? Software is a collection of programs, right? And what is a program?
Instructions.
Programs are set of instructions, right? So when we talk about software, so we also studied the difference between hardware and software. Hardware is the thing which you can touch, all the physical components, and the software is the thing which you cannot touch, right? Which you can see only.
Yes, ma'am.
Right. And softwares, also we discussed that there are different kinds of softwares, right? That will be coming in the later sections. The system software, application software, utility software, we had seen that. But here, what they are telling you is, software is your software programmer codes. A computer programmer or a software programmer writes the code for the software, right? He writes the programs, and that makes a collection of programs make a software. So it can be a business application for scientific application. And this software, what does it do? What does the software do? It instructs the hardware, right or wrong?
Yes, ma'am.
It instructs the hardware to give you a result, what the processing, whatever is done. So instructions, actually software is an instruction to do something. Right. And always remember that whatever you are writing in a computer program, it must be written in some normal English language, like program codes are generally normal English like languages, right? But whenever the software has to interact with the hardware understands binary, right? 0 and 1. So it has to convert it. So the system software converts that your information into binary form, and when it returns the result, again it converts into your human readable form. So this is what generally happens. So there is software, like we studied about the history of computers, same way, and the computers also evolved after year by year. Same way, software evolution was also there. Software also was evolved. Firstly, we didn't have what you say. We were working as on binary number system, so low level language that is machine language. Later on, it kept on advancements and different operating system and languages, different types of middle level, high level languages came into being. So that kind of a software evolution we'll be studying about. So there are different aspects of this evolution, how the software developed. So there are different aspects like software architecture aspect is there, right? So how software architecture aspect is there, like it is mainframe, file server, client server, internet based. Right, these are the aspects of software architecture. How architecture of software kept on changing. For first it was for mainframe, then file server, then client server, then internet based. Then again software design paradigm aspect also came. How design of the different languages was done. So software design paradigm had non-structured, structured and modular, object-oriented, component-based, service-oriented. So these were for the languages, how languages were developed, and these design paradigms were followed. Then programming language aspects, you have procedural language, you have object-oriented languages. So earlier C and all were procedural languages, right? Procedure is a kind of a function. So you used to write functions or procedures, and that was C language. But later on it became object-oriented, based on objects. So we'll discuss that also. Then came software licensing aspect also, right? You have made architecture software also, you have made design software also, you have been programming language aspect also, but when these things were made, then license aspect was also came into being. So where traditional single or multi-user license was there traditionally, then transaction-based licenses, and nowadays rental XP of use per month license is also there, technology partnership license is also there. So these are the different licenses for which you can buy a software, right? Earlier you have one user license or multi-user license software. Then transaction-based softwares were also there. Nowadays rental softwares are also made that for this much month you will pay this and you will use it. And technology partnership is also there. So these are the different evolution things. So evolution of software architecture, that is the first this aspect, the software architecture aspect of the evolution. Sorry. So that was mainframe. The first software architecture evolution was mainframe. So till a few decades back, all computing was controlled through the central mainframe servers, right? So before some decades, few decades back, what we used to do was there was a central server, and all the users were connected to the central server. Multiple users were connected. So what happens? So that central host or central server has to be an intelligent terminal which captures the keystrokes, send the information to the host, and display the text output. Right. So it should be a intelligent server. All the processing was done by the application residing on the main central server. So whatever processing was done by the main server only, the central server, only large transaction-oriented applications were developed during that time. Business tasks such as accounts receivable, accounts payable, general ledger, credit and account management and payroll that were repetitive and could be run as batch jobs were automated. So basically, large transaction-oriented applications were developed at the time, like you can say banking kind of an application where you can business kind of an application where your accounts receivable, payable are handled. So that kind of thing was there. So what happened in the central mainframe systems? You have a central host, that is your main central server, which is having your application database on the mainframe machine, and you have multiple user terminals. So they were connected to the central server, and whatever was accessed from the central server, whatever was saved to the central server. So this kind of a system was there. So that is mainframe architecture, the first one. So for mainframe architecture, you had a different kind of a mainframe architecture software. Then came file sharing architecture. So what happens in file sharing architecture is that suppose you have a microprocessors came into being PCs and LAN transformed dumb terminals through smart clients. So now you have PC with LAN. So now you are connected to the internet also and all that, or to the other workstations also. And also your client workstations and desktops are also enhanced capabilities and interfaces there. Application logic is there. So now the server provided access to computing resources like printers and large hard drives for storing the files. So basically what happened was your files, you have different peripheral devices you want to use. Suppose you want to use a printer, or you want to access the printer which is attached to the server, or you have a hard drive for storing the files which is attached to the server. So it downloaded the file from the shared location on the server to the client machine. The user application that worked on the data was run on the client and the file was returned back to the server. So what happened was your system is also intelligent, but what happens, you want to use a printer, you give the instruction to the server that this print command has to be given. So print is given on that server printer. A single multiple users can give commands to the single printer. And suppose you want to have a file from the server, so the data was run on the client machine, but the file was written back or saved on the, when you save it, it is saved on the server automatically. The application has to be installed on each workstation that access the file. So what happened was, you need to, for having the access of those files and all, the application has to be installed on the client or workstation also to access different files from the server. So in this architecture, resources could be added as and when necessary or desired. So you could have as many, you could add scanner also, other devices also, so that all the people could use those devices on the server and can transfer the file to the particular device. So thus it provided a low cost entry with flexible arrangement. So you have low cost entry, but what was the drawback was that application logic was executed on the client and server typically provided file to store. So basically what happened, these are not the client or workstation machines are not dumb. That means they access, in the mainframe, what was there, the central server was having all the application logic and all that, and the database is also on the mainframe. But here what is happening is the application logic is on the workstations, and the server is only for saving the thing. So the workstation accesses the file and applies some logic on that, on their own system, and then it gets saved to the central server. And you also have shared resources like database or printer or whatever, which you could access for C. So as the number of online users grew, the network traffic got congested and the file sharing got strained. So if in this kind of a system, central file server system, if number of users are increased or number of online users are increased, so what happens? The network traffic, because this is a central server and you are connected through your PC or LAN to the internet through to the central server, and what happens is network traffic, if it gets congested, so the file sharing cannot be done. So it gets a lot of time to access certain things, and it takes a lot of sometimes the connection also fails. So this kind of a thing was a drawback in this kind of a file sharing architecture. Then came client server architecture. Now, what client server architecture is, as the capacity and power of personal computer improve, the need to share the processing demands between host server and the client workstation increase. So now what is happening, that now your PCs are having more capacity and power, they are powerful computers. So now you are sharing the processing demand. That means the client programs are intelligent also, the server systems are also intelligent. So they share the workload. So they partition it. The server programs providers of a resource or service, and client programs are requester of resource or service. So basically, client program will request a service, do some work on it, and the server program will provide that particular service on the client system. The client and server may reside in the same machine, or they typically reside in separate pieces of hardware and communicate over a computer network. Generally, we say that the client machine is there and it is connected to the server machine to access different files and different peripheral devices. The server machine is a host that runs one or more server programs which share their resource with clients. A client does not share any of its resources but requests a server function or service. So basically what happens is server machine is a host or that runs one or more server programs which share their resource with clients, and the client does not share anything, any of its resources, but requests a server to function or service some request. The server program fulfills the client request. Clients initiate a communication session with the server. The client or server system may be two-tiered, three-tiered, or n-tiered. So this kind of a architecture where there is a client or a server machine. So they are also different types of client server architecture. One is two-tiered architecture. In this approach, you have a client and a server, right? So the application of business logic in client server application may reside on the server fat or thin, or in the client fat or thin server. So the application or business logic can reside on the server also or on the client also. Both can work as according. The earlier file server mechanism we have seen that the client had the application logic and all the server had the saving facility or storing facility for that. So that kind of a logic can also be applied here. Right, so here the relational database thing has come, file server mechanism has come. So two-tiered architecture was generally used at that time. So client and server interact over the network. Increase in the number of users often lead to network congestion. But only problem is here that suppose you have a server database and the client user interface is there, client is there, so it requests some file or services to the server, and in response the server fulfills the request of the client. So if the number of users or clients are increased, the network gets congested in this kind of a system. The maintenance of the application becomes difficult with more users. The lack of scalability, availability of a system to support increased demand of work, uses a service level almost instantly without any change and with no significant drop in cost effectiveness or quality of service. So basically, because as your clients increases, your server is not capable of handling all those demand of services or requests which are required, and you are not changing any hardware or anything in the server. You are taking it as and no cost, extra cost you want to apply. So this mechanism will be lot of troublesome at that time if you have more number of users. For that reason, you could go to three-tiered architecture or n-tiered architecture. So what is three-tiered architecture is a new generation of client-server implementation takes a step further and adds a middle tier in between client and server. So now you also have one more tier added in between client and server, that is known as middle tier. And the three-tier architecture attempts to overcome some of the limitations of two-tier by separating presentation, that is user interface, processing, business functionality, and data into separate distinct entities. That means your user interface is separate, your data is separate, where it is stored or whatever, and the presentation or the front end is separate. So this leads to enhanced network performance and improved extensibility of business systems. Still, it has been found that three-tier methodology lacks some critical features such as reusability. So reusability is not there. What is reusability? The ability of a computer program to be used repeatedly with little or no modifications in many different applications. So basically, where you want that your application is used in different the different applications could have different modifications or they would require different things. So repeatedly you cannot use the same program repeatedly. So reusability is using a program multiple times. So that could not be possible here. if we don't modify because we want to use it on different applications. So the scalability becomes a problem. So there may arise a situation whereby a collection of application logic code cannot be reused and also they do not communicate with one another. Thus, there can be a need for viable architecture that mainly facilitates reusability of business logic. So we want, nowadays what is happening is we want the thing that reuses the code so that we don't have to rewrite the code again and again, or we do not have to change the business logic but reuse the phenomena again and again. So that reduces the cost of the software. So we want that kind of an architecture nowadays. But 3-tier was good if you want to unload the thing in 2-tier architecture. So you had database server, you had application server, and you had client. So client request to the application server. Nowadays, this kind of an architecture is also followed in some websites or something like application, or you can say web servers. So client requests to the application server if it is a request for some file or something which is in the database. So the application server goes to the database and fetches the files and gives the response. Or if it is for some business application logic, the application server fulfills that and gives the response to the client. So this is so two servers are here then. A middle tier 3-tier architecture is there, right? And where then comes the n-tier architecture. So here what is happening is 3-tier architecture can be extended to n-tier when the middle tier provides connections to various types of services, integrating and coupling them to the client and to each other. So basically application 1 server, application 2 server, and database. So you have different kinds of application servers, or the you can say middle tier is you extend the middle tier here. So because one application server will do something, the other application server will do something. So various types of services can be taken care of, right? So partitioning the application logic among various hosts can also create entire system, right? So encapsulation of distributed functionality in such a manner provides significant advantages such as reusability. You can reuse the application logic here, and thus reliability, ability of a computer program to perform its intended functions or operation for the specified period of time. So basically reliability means that without failure, if your computer is able to perform the functions and this, so that is a reliable system. It is not failing. So now what is happening is it's generally a kind of a web server kind of a thing. So you are connected to the internet through the browser, the client request to the application web server, and if the application web server can also have another server which can also fulfill the request of the client, and if it requires database services, so it can also go to the database services and its response is given. So this kind of a system is n-tier. So your middle tier is n number of times you can have the middle tier. So that is another. And now you have the latest one is you have internet-based architecture. So internet-based architecture, in this you have a web server, you have an application server, and you can have a database server, right? So a browser connects to the internet through the browser through HTTP, right? On the web server, like you open a website, right? You write some you want to search something or whatever you want to do, or you want to fill a form on the web server. So it goes to the application server and finds the forms given to the client browser, and when the client browser fills the forms, then it gets saved in if clients presses submit, then it gets saved to the database and a response is sent to the client that your form is filled. This kind of a system is known as internet-based system. So they also have certain advantages. Nowadays, client and server trend is through the internet only. Client and servers are handled through the internet. You are the client, and the servers are your web servers or your internet servers. So they fulfill your applications things. So they are specifically made for web applications, basically, for your websites, online transactions, web mails, all those things. So that is your internet-based architecture, right? Do you understand these architectures? Mainframe
Yes, ma'am.
mainframe architecture and your client server architecture, which has 2-tier, 3-tier, n-tier, and internet based, right? Then another architecture is also come. Do you know about cloud computing? Anybody knows about cloud computing?
And when we store our data in the cloud servers, is that it?
Yes. So what is cloud computing?
Cloud
Is
means
it
virtual, ma'am.
what?
Cloud means virtual.
Cloud means what?
Virtual store, ma'am.
You can
Virtual
say it is a
computer.
virtual storage, yes. But
Yes.
what does
Does not require hardware and software.
yes?
Any software.
No, it does not require any hardware or software. What does that mean? Is suppose like you are using at your home electricity, right? Are you using electricity? Right? Everybody is using electricity.
Yes,
So
ma'am.
a bill comes to your house that this much electricity you have used and you have to pay this much. Yes? Yes or no? Pay service, hai na?
Ye- yes, ma'am. Yes, ma'am.
Right. Same way in the cloud, what happens is you don't have a particular software, you don't have a particular hardware, suppose, in your system, and you want to use that particular hardware or software. So cloud is providing that. Do you understand that?
Yes.
Right.
Yes,
So
ma'am.
you request that I want to use this particular hardware or software for this month. In that is, but depends on the structure that how much usage you are doing. Suppose you are using it for a week, they have some payment structure. For you for a month, they have some payment structure. For a day, they have some payment structure. Do you understand that?
Yes, ma'am.
And the sum of the for those services you will pay them. And for some of the structures, what they have done is like for the storage. Suppose you want to store on the cloud, they also have storage facilities also. So it is stored on the cloud, not on your system. So on the cloud, some companies like for your mobile companies, they are giving you free cloud service for certain limit. That this much data you can keep it on the cloud. Do you understand that?
Google Photo.
Yes.
Yeah, Google is there, then Samsung is also giving for its clients. So different structures of things have been opened. If you use more than if you have used that much data, then they will start charging you money. They will say if you want more storage, then you have to pay for this. Free is this much,
Yes.
after that you have to pay. Right.
Yes,
So
ma'am.
that kind of an architecture is cloud computing. So it has generally evolved from mainframe based architecture where computer programs are exclusive property of the developer. Generally, earlier what was happening was you if you want to use it, the programmer who has developed it is a property of the programmer, right? And then your copies of that license you have to buy, and then you can buy that particular software. Yes or no?
Yes, ma'am.
Right. So nowadays you don't want to buy a software, full software and keep it on your system, and that is your own software because you have bought the license for that. You can also go for cloud services that you don't want that for such a long time. I am going to use it for one application, so I don't want to buy the license. So what will I do? I will go to the cloud, ask for the service, I work on the cloud, they will give me a username, password to work on the cloud. I will use that particular software for whatever days I need, and then my work is over and I'll stop the service. Right. So that kind of a system is your cloud.
Ma'am, is Office 365 is example of cloud computing?
Yes, it's a kind of a cloud property also. It works both ways, licensing also and cloud also.
Okay, ma'am.
Ma'am,
So yes,
can't we include online gaming or online streaming platform in this section?
you can. You can say that, but for that you are playing games on the cloud and they are charging you something, that can also be possible.
Have you heard the name Stadia from Google?
No, bro.
Stadia is a platform for like gaming, but you don't actually need to have that kind of configuration. You can use an external server, play
Yeah.
on that, but it will be
That is
shown on
Google.
your screen.
That will be Google server you will be
Yep.
playing on, and you will just be paying for the thing for
Mm.
how much you will be using that.
Yes, that's Google Stadia.
So these cloud-based services typically mean that the consumer does not own the hardware and software, but still gets the desired service. So you don't own it, you don't buy it, or you don't own it, but you still use that particular service. So in an IT delivery model that offers large-scale shared infrastructure and computing resources as a service through self-service pay-per-use access. So basically, it is a share infrastructure. Suppose you have a cloud, so you are somebody else may also be using that particular thing, and you are also using it. So it's a shared infrastructure, and you have whatever you are doing on your self service, you will be paying pay per use access will be there. You have to pay for that particular thing which you will be using. So that is a cloud computing technology which is now trending itself, right? Nowadays it is in the market. So as the new software vendors try to establish themselves in the market, they created solution differentiators which provide unique value to the consumer. An example is Salesforce.com, which from the inception offered a hosted customer relationship management solution, while its established competitors, Siebel, SAP, Pipa, etc., had their traditional also called. So what is this? Suppose you want that customer relationship management CRM software. Suppose some companies make their own software. These customer relationship management software like Siebel, SAP, and PeopleSoft, they have their own softwares. But some companies can also go for like Salesforce.com is a site where they can have this customer relationship program running for certain number of days. They can buy that and they can use it, and then they can pay for that CRM solution. They don't want to. They don't want that the software should be developed and given to them. They would buy the license for that particular software, customer relationship management software. They are just using it somewhere for certain, paying the particular vendor the money for using it for whatever months or days they are using. Do you understand? So that kind of a thing is cloud computing. So this is nowadays the most trending thing which is there. And also an early example of cloud-based computing is your web-based emails. Is it not cloud things? Your emails?
टाइप करके
Hotmail, Yahoo, Gmail, they are all what?
Yes,
Whose
ma'am.
mic is on? So nowadays your emails are your web, the cloud-based services or not? You are using Hotmail, Yahoo, Gmail, all that.
Yes, ma'am.
Yes,
Yes,
your
ma'am.
chatting things also. So you that is a cloud-based service only. For this much limit, your email is free. Then they will start charging if you have more things. So that is what cloud is. So what is the features of cloud computing? So they may ask you a question: what is cloud computing and what are the key features of cloud computing? So you can first is infrastructure sharing. Yes or no? You share the infrastructure, hardware or software. The dynamic sharing is there, right? And it is also cost effective. Yes or no?
Yes, ma'am.
You don't have to spend lakhs of money
Yes,
on a
ma'am.
particular software. Just for a small amount of money, you can use a particular software or hardware.
Yes.
Right. Then scalability is there. Why scalability? That to handle ever increasing workload demands and support the entire enterprise, cloud computing must have the flexibility to significantly scale its IT resources. So basically what happens is cloud computing should be scalable. Scalable means it should keep on increasing its infrastructure. Why? Because as and when demand occurs, suppose more customers are accessing the software or hardware, so you should have those kind of thing, a hardware structure which is more scalable, which can meet the demands of the users. Do you understand? So more hardware you have to keep, more storage you have to keep, more software you have to keep, and keep on increasing the IT resources, right? So that is known as scalability. So it is scalable. Cloud computing is scalable. And self-service means cloud computing provides customers with access to IT resources through service-based offerings. The details of IT resources and the setup are transparent to the users. What does this mean, self-service? That means the software you are giving them, but not at their own machine. They are using it and they don't know the setup or things, or that is transparent to the users. That means you have to use the software the time you are given, and the result you can take it on your system, but you will not be able to have the actual software on your system. And you have to understand your things yourself. You will have a username, password. Self-service is there. Whenever you want to use that particular cloud computing thing, you have to log into that particular username, password, and you can access that particular thing and use it. And when you log out again, the thing is on the cloud only. It will not be on your system, and it is pay per use. Right? How much you use, you have to pay for that. That is what is the thing. So these are the key features. So there is also another term that is associated with cloud computing, like software as a service. Have you heard about that? SaaS. Then PaaS is there, platform as a service.
Yes, ma'am.
That means you can use a software on demand software, which is known as. So this is a software solution delivery model where the software and the associated data are hosted centrally in the cloud and are accessed by the consumers through a thin client such as a web browser. Common applications for this are business applications such as accounting, collaboration like email, messenger, web meeting, customer relationship management, enterprise resource planning, human resource. So these are the platforms which provide you on-demand software as a service. So that is there, or platform as a service is also there. So key benefits, features and benefits, what does that mean? Both are the same thing. So what are the key benefits of using a cloud-based solution? What benefit you get? First is the cost, right? Low cost. You are not paying a large amount of money. You have to pay per user. So it is low cost, right or wrong?
Right, ma'am.
Right.
And it takes less time to get a customer going on a cloud solution, lower time to market. Yes?
Yes.
Suppose you want to have created a particular software, you have to first market it so that the people should buy it, buy the license, right? But on
Yes.
the cloud, you will find many number of applications and you will see which application to use. So no marketing is also required. You will always be on the cloud and see which application I want. If you like that particular application, you automatically go to that to use. So that it allows the company to focus on the core business and not worry about hiring and constantly training its staff on new technology. Right. On the flip side, for a cloud-based solution, certain segment of customers such as large banks and financial institutions and insurance companies may have security constraints. Yes or no? There are certain problems in which they are catering to, that is cloud security. So many bigger services like banks and financial institutions will not be going in for cloud because your data is resided somewhere else. Yes, on the cloud, and you don't want that your data should be on the cloud. Yes or no?
Yes, ma'am.
It should be on your own data centers or database, not outside. So that because of that reason, they will probably not be going in for cloud services, these kind of services, because these are financials, and if such some person's data is gone to the other side, so it will be a problem, right? So those this is also another thing. Then we had talked about, these were the things which we talked about were architecture based. Cloud is also an architecture, cloud computing is also architecture, software architecture based. Another is software design paradigm. So design paradigms, as the software evolved in its complexity, architecture and use, and as the programming language got better, styles of software programming also changed. So software programming also kept on changing, its design also kept on changing. Like earlier we wanted that software should be some design should be there, then reusability came. Then we want that it should be reliable, more reliable, easily maintainable. So these kinds of things kept on appearing in the software design. So first design which was there, first design paradigm which was there is non-structured design paradigm. Non-structured means non-structured programming. Do you understand what is non-structured? Non-structured means a program usually consists of sequentially ordered statements. That means sequentially ordered means what? That there is no thing where you can take. You have your lines of code are labeled. You cannot to allow the lines are usually numbered or labeled to allow the flow of execution to jump to any line in program. There is no concept of procedures in non-structured program, and there are no independent reusable. So basically, when we talk about non-structured means there is no functions or procedure. Do you understand what is if somebody has done programming, they may understand what is a procedure or a function. What is a procedure or a function? A procedure or a function is a set of instructions. Like a program is a set of instructions, right? Same way, a function is also a set of instructions. So like if somebody has used Excel or some kind of applications, so we use equal to sum, right? We use that function or not?
Yes.
Yes.
Yes. So that is a function. There is a code behind that function, the sum function, and in the parenthesis we just give the parameter that 5, 4 if we give equal to sum 5, 4. So what will it give me? The addition of the 5 and 4, right? So we don't know what is at the background, but that function can be used as many number of times or not?
Yes.
Yes, the sum function can be used as many number of times. So that is known as reusability. That's the same function I can use as many number of times. Right. So in non-structured things, this was not the thing. There was no function, no reusability. Just you need to kept on writing the program code line by line by line. You could write. Right. There was no structure, exact structure. That suppose you want a function, then you can call a function here equal to whatever function you want to call. There was no such concept in non-structured program. So no independent reusable unit was there. The separate units were not there. Suppose I want to make a program and I want to find the area and perimeter of a rectangle, suppose. Right. So I'll make a function separately for the area and I'll make a function separately for the parameters if I make that. So I'm dividing my program in two separate functions, right? And I'll be calling both the functions somewhere in my main, right? So that is structured. But in non-structured, I have to make the area in the same program. I have to make the perimeter also in the same program. Right? There is no separate module or separate functions for that. So that kind of a thing is non-structured. Sequence-wise, just keep on writing the code of the program. So your program flow will be like step 1, step 2, step 3, step 4, like that. Like here they have given some code, integer I is equal to 12. They have defined a variable I, right? First you need to understand what is a variable. In a programming language, in any programming language, whatever language you study, there will be variables, there will be constants, right? So what are variables? Variables are storage locations, and the value in those particular storage locations can change. Value in I can change, right? And I have to define what kind of variable is I, that is known as data type. That means I have to tell the program that I is an integer, a number has to be given. So that is data type. So we have defined that integer I, that means a variable has been declared integer type I, and I have put a value 12 inside I is equal to 12, and then I'm saying go to 10. Go to 10 means the label 10 is there where it is written print asterisk comma line 10. Right, so it will go here and it will print asterisk and line 10, right, and then after that it is go to 2, so it will go to second 2 label, and there it is written continue, so it will say I is equal to I minus 1 if then one I is decremented I minus 1, that means I becomes 11. If I is equal to 0, go to 99. I is not equal to 0, right, so it will again minus 1 and keep on minusing until I becomes 0, and when I becomes 0 it will go to 99 where it is written continue. Do you understand?
Yes.
This kind of a structure is known as non-structured programming, right? There is no function or nothing. Your program is simply set of instructions and you have to follow those instructions. The computer will follow those instructions. So that is it. And even if it is going to the particular go to 10 or go to 2 particular line of code, it is going. Nothing else is there. Right. So structured and modular design, this is a non-structured design. Then structured and modular design is where we make modules or where we make functions or structure based. Right. So design introduced the concept of selection and repetition of statement in code. That means we can reuse the code. Right. So like we write procedures and functions. So function is a block of code, right, for doing a single task. Suppose I am finding an area of a rectangle, so that is a single task, and another function will be perimeter of a rectangle, that will be another function. So it is a block of code or set of instructions, right? So I can use this area of a rectangle and pass the parameters. I can pass as many parameters as I want. Suppose first time I pass 3 and 2, second time I may pass something else, like it in Excel you use sum, same way. So you can use this particular function in your program as many number of times as you want. So that is structured programming or modular programming. Procedures and functions which were similar purpose were grouped together to get a module. And if you group number of functions or number of procedures together, so you make a group, a module. Right? That means your module is doing what? It is finding out the area and perimeter of a rectangle. You have clubbed both of them. That is, you have made a function for area, you have made a function for perimeter, and you combine it in a group that is known as a module. So that becomes a software, right? A big software application consists of multiple modules. So when a software application is talked about, any like Word or Excel and whatever software applications are there, so when we combine the multiple modules, whatever modules you have, different modules which have different functions, so when we combine those modules, a particular task is performed, and that particular thing is the software application. This is how a software application is made. So that was structured on modular design paradigm, where you have this kind of a structure. You have step 1. So step 1, you test the condition. It may take this step 2, it may take step 3 according to the condition, yes or no, right? And step 3 can call a function which is another code, and step 4 can call that function. So this kind of a structure is known as structure based programming, where this particular code is used by twice it has been used, reusable. It is reusable, twice it has been used. So this kind of a structure is known as structured programming with procedures. So like here they have given you a code. No, they will just like they are saying that accept user input in X. So in X you will take input from the user. If X is even, you will check whether X is even, then add 1 to X. So X is added with 1. and then a procedure is called print prime x, right? This is a procedure or a function. And if x is not even, then else part is that x may be odd, then they will call the print prime function here also. And the procedure of the prime print prime is this: accept y and check if y is a prime number. If y is prime, display y is prime number, else display y is not prime number. So this is the function, this is the procedure which are being called by here also, right? So this kind of a structure is known as structured programming language, where you can reuse a particular code in when you make functions, and the modules also combine. Then another concept is object-oriented design. Object-oriented design nowadays, most of the languages are object-oriented languages, right? So here what is there? You also compartmentalize and reuse the code here. Both the things are there. Compartmentalize means you can put a code inside a container so that the outside people doesn't know what is inside, but they can use that particular thing. That is compartmentalized. Like you are using some function, but you don't know what is the code behind the sum function, what it will do, but you can use the sum function. So that kind of a thing. And the concept of object-oriented design is it is based on objects. And what are objects? Objects are real-world entities. Real-world entities means like whatever you see around you are real-world entities. You see a chair, you see a table, you see a person also, human being also, animal also. Whatever you see is an object, right? And on those objects you are programming. That is object-oriented programming, right? So there are different concepts in this. Like you have object, you also have class. Now suppose when we talk about class, what is a class? When we combine suppose in a class we say that the objects may be chair, table, whatever are different objects. When we say in a class, so that means all the in a class, all the things, if we see whatever things we are seeing in the class, that will make a compartment, right? That will be a class, right? Like for example, school and students are objects in real world. Yes or no? School and students are objects in real world, right?
Yes,
Yes,
ma'am.
ma'am.
They would be considered objects in object-oriented design also, and they would interact with each other through messages. So school will have some properties and methods. School will have properties like school teaches students, right?
Yes, ma'am.
Takes admission of the students, right? And methods is method can be teach or whatever it can be. So those, and student also have certain properties like student ID is there, name is there, and roll number and address and all that. Same way school will have school ID or school name and address and all that. And the methods are that it teaches, takes admission, whatever. So same way student also study and take admission or whatever. You can say these are the methods. So how does these two objects interact? Through messages. They interact through messages. So school may ask what is your address, and the student will return that my address is this. Just a kind of a message they are explaining. So these are the objects. Now if we encapsulate, encapsulation is another concept of object-oriented. What does encapsulation mean? Like you have seen a capsule, the medicine, right? Inside the capsule, the actual medicine is there, and outside a shell covering is there. Yes or no?
Yes, ma'am.
Right. So you don't
Yes,
know
ma'am.
inside what medicine, what color of the medicine is inside, but you eat that particular capsule. So you don't know inside what is there. Right. Same way in object-oriented, encapsulation is one of the concepts or basic principles where you conceal its data or properties and methods inside one object. An object's ability to conceal its data and properties. Conceal, what does conceal mean? Do you understand? Put inside a compartment. Conceal means hiding from outside, put inside the compartment. So that is concealing. So when you put your data and methods inside a compartment, that is known as encapsulation. And that is what the class concept is all about. The encapsulation objects only publish the external interface. That means you know the outer surface only, you don't know the internal things. So you will be interacting by the external thing, you will not be interacting with the internal things, because internally what is happening, you have no idea. So you are ignorant about the internal things. Like you do driving, right? Driving of a car. You know that you have to press accelerator, clutch, brake, and steering, you how to handle that. But do you know what is happening inside the engine when you press the brakes and when you press the accelerator? What is happening inside? You have no idea. Only the external thing you know how to do it, right? So that kind of a thing is known as encapsulation. So there are many concepts in object-oriented. There is also a concept of inheritance. Now, what does inheritance mean? Inheritance means like from your parent, you inherit certain properties in yourself, right? Every child inherits some properties of their parents. Yes or no? Same way here in object-oriented, suppose you have a vehicle class, that is the parent, right? And vehicle class child are automobile and bullock cart and whatever you can say. So they are the child, right? So vehicle will provide certain properties to the child classes, like vehicle has wheels, so both of them can have wheels, automobiles, and the bullock cart will also have wheels, right? But how many wheels will be their own? That means the child can take properties from the parent, and it can have its own properties also, right? So its own properties will be that that it has engine, automobile has engine, but the bullock cart doesn't have engine, right? So they will have their own properties. So that kind of a mechanism is also is there in object oriented. So there are many mechanisms that they have talked about certain things, and you could make modular programming. You could reuse the code, and your applications can be broken down into different things. So that is what object oriented programming is all about. So nowadays, generally, object oriented programming languages are used generally. Another is component based paradigm. The concept of object oriented paradigms were extended to component based. So after object-oriented paradigm, it was extended to component-based programming. Component-based development owes many concepts to object-oriented methods. It gives a more abstract view of software system than object-oriented method. This model prescribes that programming problems can be seen as independently deployable black boxes or components that communicate through contracts. So basically, what is this component-based paradigm is that they have extended the object oriented into component based, and it gives the abstract view. What is the abstract view? That again the problem is seen independently, and a black box kind of a thing is seen. A component is created, and you communicate or contact or have the solution through that black box only. Inside what is there, you don't have any idea. So the meaning of component or component-based programming is intuitive. Programs are broken down into primitive building blocks which may be flexibly plugged together according to well-defined protocols. So that is what component-based is, that you have to create different components, right? And independently developed component off-the-shelf codes is a plug-and-play manner. For example, a shopping cart website application may use off-the-shelf credit or card authorization component. Do you understand what does that mean? Like if you go to a shopping website, shopping cart website application, so they may have a separate thing for the credit card authorization component. They must have not developed it. They have taken it from somewhere else. The component has been added to their application. So inside what is there and how it is acting, they don't have any idea, because they have not developed it. They have taken it from outside. So that kind of a thing is component-based systems. So components exist at different sizes varying from single objects inside a library to whole application. In most cases, our components are larger entities and contain several objects. So basically, it can be a library file or it can be a whole application also. So large, generally it is a large entity, and you don't know any idea what the inside the component what it is doing, but you know how to use it, and externally only you are communicating with that. So it is just like a starting platform for service orientation, whereby a component is converted into a service. So you are just using that component. You don't know what is inside, what programming has been done, nothing you know. So that is component-based service. Right. Then is service-oriented paradigm also, which is also built on object-oriented programming and adding the premise that problems can be modeled in terms of services that an object provides or uses. So service is a unit of functionality defined by a set of message exchanges that are expressed using an implementation neutral grammar. So basically here, a service is just like a you are asking for some message exchanges that this service I want, and you will get in response a particular service which you are accessing. Just like in client server application you were doing, service oriented paradigm is there. So you request a particular service and that service is fulfilled to you. So that is what service oriented paradigm is there. That is again, you will use the reusable code that I want this, so the code the thing is integrated into the system is created where different reusable codes have been added and the services are provided to different set of customers through service oriented paradigm. So that is known as service oriented. So it is again reusable. So this is according to software design paradigm. Design, you have non-structured, structured, object-oriented, component, service-based. And then comes evolution of programming languages, how programming languages develop. So we have seen that you have software architecture design, software architecture also design-based also. And now we are seeing what are the different aspects of programming languages, how they evolved. So as a programming language, you have procedural language and non-procedural language. So what are procedural languages? Procedural languages are could also be called linear programming, as one thing happen then the next. Linear programming, do you understand? One thing is happening, then second thing will be happening linearly, sequentially it will be going on. Each instruction is executed in order from the top to the file to the bottom. Sequence wise the instructions are solved. That is known as procedural. So it focuses on the idea that all algorithms are executed with functions and data that the programmer has access to and is able to change. Some languages which support procedural programming are C, Fortran, VB. VB is Visual Basic. So how does a procedural language works? You need to create forms for online inventory system for an automobile part manufacturer. You are asked to design two separate forms, one to process information about cars and other about trucks. So what is happening is you have to make a online inventory system for automobile parts. Suppose example for a manufacturer, and you want to design two separate forms, one to process information about cars, the other will about the trucks. So for the cars, the information is color, engine size, transmission type, number of doors and make. And for the trucks, it is color, engine size, transmission type, cab size, towing capacity and make. Right. Now they are coding it. So for the first one is your C. Here, what does global variable means? That in both the forms, two or three things are common: color, engine size, and transmission type. Yes or no? These three things, these three things are common in this. So they have been made a global variable here, right? And make these have been made a global variable. So color, engine size, transmission type and make. And in the program, if requested for call car procedure, if requested for truck, call truck procedure. So they are calling the procedure if car is called or the truck is called. If car is called, this procedure will begin. And here they have made also local. The car will have number of doors, its own variable, so that is made, and process car information. So car information will be processed. If truck procedure is called, then it has its own variable like cab size and towing capacity, and the truck information is processed. So if we need to add form to process information for bus, then we need to change the main program and add code for bus form also, right or wrong? Now if we want to add one more thing, that is bus, right? So bus will have some color, engine, transmission type, and seating capacity. It will have its own, right or wrong?
Yes, ma'am.
Right, make and all that. So if I want to add this in the same program, will I be able to add the thing in the same program? Bus thing. We have to change the program. Many things have to be changed in this program then. Right, but if there is a change in the processing of all the vehicles, then we need to make changes to all the forms. And if we have to make the changes in all the vehicles, suppose all the vehicles have some kind of a change, then we have to change all the forms, yes or no? If we need to add any specific information for cars, then we need to create multiple forms, one for each way. Also, we need to be careful about changes to the global variables as all the forms are accessing them. So this kind of a thing is structured programming. This is known as structured programming or procedural programming, basically procedural language, where you write procedures and you call the procedures as and when required. Right. So if you want to add more procedures or if you want to add more things to this, so you have to make changes in your program. A lot of changes have to be required in your program if you add bus or more items to your program. That is known as procedural. Procedure or functions are means the same. Set of code, set of instructions which can be reused. Functions can be reused n many number of times. So you can use this procedure or function as many number of times you can call it. Right. Same way you have object-oriented language. Object-oriented programming is more abstract than procedural programming because it looks for patterns and reusability. The same code can be loaded and executed many times to accomplish a task without having to retype it. So you can use the same code as many number of times as you want, right? Reusability is one of the things. Encapsulation is one of the things, the concept which I was telling you. Object-oriented have many concepts like encapsulation, where I was saying that you are keeping the implementation inside a container. You are wrapping the implementation or details inside a container, and the usage will be from outside only. You will not be seeing inside what is happening. The set of all messages the object can respond to. So through objects or through messages you will be interacting with that particular encapsulated code, and you don't know inside what is happening. Encapsulation prevents code and data from being arbitrarily accessed by other code defined outside the wrapper. So it will not allow code and data to be accessed outside the wrapper. If you want, it has to be encapsulated or kept inside a wrapper. And inheritance is
Ma'am, can we call it as a source code?
No, it is not like a source code. It is generally you can say a kind. One more concept is there, abstraction. Hide the unnecessary detail to the outside world. You don't want to show the necessary detail. You have just kept inside the container, and you can have interaction with that from outside through messages. It's not a source code actually. Source code is different.
Okay.
Inheritance is just like how you create a class from an existing class, a new class from an existing class, right? A parent class can produce a new child class. So you are in a way compartmentalized and reused, since it allows classes to inherit commonly used state and behavior. So what happens is Suppose my parent has a method and I am the child of that particular parent. So I can access that method because I am the child of that parent. Do you understand that? So I can access that method. That means that method is defined in parent class, and that method I am also can reuse because I am the child of that parent. So reusability will be there. And new classes are called the derived class, and the main class from which it is derived is called the parent class. That is inheritance. So you can inherit. Inheritance basically helps in reusing the code. So if you make a child class of a parent class, so parents methods can be used in child class also. And what is polymorphism? Polymorphism is the characteristic of being able to assign a different meaning specifically to allow an entity. Like poly means many. Poly means many forms. Poly means many forms. Morphism means forms. Poly means many forms. So basically, one function can do multiple things. That is polymorphism. Suppose I have made a add function, and that add function the same function name can do multiple things. Like if I want to add integers, so the add function same name, but it will add integers. Then add function can add float, that will be separate. That would be another function, right? Then I can also have the same name add for adding two numbers. I can use add for adding three numbers. So that is known as polymorphism. Same name but doing multiple things. So that is polymorphism. So it is the ability to process objects differently depending on their data types and redefine methods for derived classes. So different data types also you can use polymorphism. So it will help you. Right. Also, you have a class. A class is a set of functions that work together to accomplish a task. So you can make a class in your C. You have objects. Objects receive all of the characteristics of a class. Right. So that is there. You have method. You have parameter. Right. Different types of parameters or properties of sets are there. So these are there. What are the different languages which are object-oriented based languages? You have Smalltalk, C++, Java, C#, Python is also kind of object oriented. So that is what is there. Acha, have you heard about compilers, interpreters, and assemblers? Has anybody heard?
Yes, ma'am.
So do you know what is a compiler?
Yes, ma'am.
So my particularly compiler just read all the code and compile it at a one go, and interpreter just compile the each line of that, run each line of the code.
Right. So compiler, first and foremost, the definition of a compiler is that it interprets the code or converts a high level language code into machine code. Do you understand? First definition. What does a compiler do? It converts a high level language, which is an English form language which we write, into your machine code, that is binary. Right? That is the work of the compiler. Right? First.
Yes,
now, interpreter also does the same thing. It converts a high level language into machine code, but compiler and interpreter have one difference, that compiler, what the person right now told is correct. The compiler compiles the whole code in one go and find out what all errors are there in the program. So it gives you all the errors, right? But interpreter, what it does is it interprets line by line. That means if it finds error in the first line, it will stop. It will not go to the second line, right? And it will give you that this is an error. When you solve that error, then only it will interpret the second line. Do you understand that?
Yes, ma'am.
But this is not the case with compiler. Compiler compiles the whole program in one go, and all the errors, whatever errors will be there, it will show you. Once you solve all the errors, your program is compiled. Right. So which one will be faster, compiler or interpreter?
Compiler.
Compiler.
Right. So do you know about C++ has a compiler, Java has a compiler? Yes. What
Yes,
does
ma'am.
Python is? Python
ma'am.
is an interpreter-based language, not a compiler-based language. Do you know that?
Yes, ma'am.
So that is also one of the things. That is also a software which you should know. So like they have made a class called vehicle, right? And they have put color, engine size, engine type, these variables they have declared. And this is a color method they have created to store and update the color, and this is engine size method they have created to store and update the engine size. So this is how you create a class, right? This is a class they have created. As and when whatever methods you want, you can have that. And class car inherits vehicle. So this was vehicle, right? This was vehicle. Vehicle has color, engine, transmission type, make, and it has methods like color, engine size, transmission type, and make. This was vehicle class. Now the car inherits vehicle. That means vehicle is the parent, car is the derived class or the child class. So it can the car class has its own variable called number of doors, and it can also access the methods of its parent, that is that is engine type, make, and all that, color and all that. It can also access because it is the child of vehicle. Same way, truck also can inherit the data of vehicle, because truck it is written class truck inherits vehicle. So this truck is also the child of vehicle. So truck has its own variable cap size and towing capacity, and other variables or methods it can access from the parent class also. Right. So now in this case, if we need to add form to process information for bus, then we just add one more class bus, which is again inherited from the vehicle class. And if we need add any specific information for car, then again we can add make specific classes which can be inherited. Do you understand what is the difference which we had studied earlier? Now if we add in object oriented, if we add another bus, we need to add another class here. No need to change any code further. In procedural programming, we needed to change the code if we wanted to add one more thing. Here we need to, if we need to add a bus, we just need to add another class, and bus can be added, and more vehicles can also be added. And if we need to change certain things in the cab, then the more class can be added, or this class can also be edited, the car class. So it is easy for here to implement more changes, or to add a certain code in object-oriented programming, right? So this kind of a thing is object-oriented. So according to the language paradigm, you have procedural language and object-oriented language evolution. And according to licensing, so licensing we have seen that you want that your software should be used by other people. So they introduced software licensing at that. Until early 1970s, sharing of software was the accepted norm. Hardware came bundled with software products which could be freely distributed, and access to source code allowed its improvement and modification. So basically in 1970s, nothing was there for what? Licensing. Anybody could use, if they have bought the hardware, they could use the software and they could distribute it freely to anybody. So there was no concept of licensing. So what happened in the late 1970s and early 1980s, companies began imposing restrictions on programmers through copyright. So what does companies started doing? They wanted to restrict programmers through copyright. They achieved financial gain by selling rights of use of software, and rather than giving the source code. So they don't want to give the source code, they wanted to gain financial gain. So they used to sell the software for some money. So this led to introduction of software licenses which govern the usage and redistribution of software. So this concept what led to software licensing, where if you want to buy the license of the software, you have to give this much money for the software. And this way you could redistribute or give other persons the different license and they can use the software. So during this time, most of the companies develop proprietary software. What does proprietary software mean? Paid software. That means you have to buy the license. That was actually the property of the company, came without the source code. There is no source code for this particular software. You have to buy the license and use it. And the users basically bought the right to use it in the way specified under the license agreement. So as the license agreement is there, you can use it. It can be a single user license, it can be a multi-user license. Then in early 1980s, another concept came of open source software. Proprietary software and open source software. What does open source software? Open software means open source software comes with source code and a license that allows modification and free distribution. Do you understand?
Yes, ma'am.
It is not that you have to buy the license. There are certain software for which you don't have to buy the license. You can use it freely. There are certain softwares where you have to buy the license and then you can redistribute it or use it. The source code will also be provided. But in proprietary, no source code is provided. Right. So these were the two things. So types of software licensing, you have individual license. That means perpetual lease license you have your own, right? Perpetual license allows you to install and use the software indefinitely. How much number of times you want to use it doesn't matter. And a subscription based license allows you to use the license for a specified time. After you may renew the subscription or remove it. So you have subscription based license and you have perpetual license and individual license, single user license. Perpetual means as when you have bought the license, you install it and you use it indefinitely. And subscription based means you have to renew the license after certain number of subscription year, if you have taken year, 2 years or whatever subscription you have taken. And open source licenses, it grants you the right to freely modify and redistribute the software. So you have the code, open source license you have, so it gives you the right to freely modify, change the code and redistribute it. And what is commercial license? These are mostly for large enterprises that use software for commercial purposes. So basically following are the main licensing models: traditional model, transaction based models. So these are the models, rental models. So here when we talk about commercial licenses, then large enterprise that use software for commercial purposes. So those they have their own models. Like traditional model is, this includes single user license, multi-user shared license, temporary or fixed period license. This has mostly been used for large proprietary mainframe applications. So in traditional model, you have single user, multi-user, temporary or fixed users period license. So this was there. And transaction based model, here the pricing is based on providing a committed business service. For example, processing payroll for a global company as part of HR offering, and this can be priced per employee. So basically, if you have a transaction based model license, so what will they do is the HR payroll software will be there, and that per employee they have to pay. If they are using it, how many employees they have, for that particular number of employees they have to pay some amount. So larger the employee base at a given location, lower the price on employee can be. This model came into existence with the evolution of software architecture from mainframes to internet based. So as mentioned before, when a company provided a particular business service, its clients could access the system from anywhere over the internet and they need not bother about maintaining the database or software system. The service provider then charges them for each transaction or record processed to their system. So they charge according to the transaction which is being happening. Then you have rental model. This has come into picture as a software as a service, the cloud one, right? Evolved over a period of time. However, the buyer need make upfront investment in hardware and software, rather than these cards come as bundled service for them. For example, where there are prevalent are finance and accounting, core finance, human resource, analytics, So these are also scenarios where the software vendor provides subscription of a given solution. Example, Windows, Azure, Sales.com, Siebel On Demand, Amazon Web Services. So they are monthly payable, annual payable basis, right? So rental model license also you can take. And technology partnerships are also there, like agreements provide the consumer unlimited access to vendors' technology. Such contracts are typically multi-year in nature, where the consumer pays a fixed annual fee, which can be adjusted in subsequent years based on the matlab, MOU is done that a partnership is there, and the vendor can use a license for this much period, and a particular annual fees charged every year for that particular software. For example, a large corporate customer deciding to use Oracle suite of ERP, finance or HR database or customer relationship management, business intelligence. So these kind of a multi-year partnership license are also there. So these are the different licensing things which are there in your according to the software. So according to software, your software developed evolved from architecture to software design to programming language to licensing. So this is how your architecture came into being for the software, right? So this is what is there in this particular thing, right? Then we talked about one more thing was types of software. Yes or no? We talked about types of software earlier also,
Yes.
right? So we had system software, programming software, application software. They are classifying in your book. They are classifying as system software, programming software, application software, right? So when you talk about a normal system, you have hardware, right? Above the hardware is system software installed. That is your operating system. Yes. Yes or no?
Yes, ma'am.
Then you install on your operating system certain programming software, certain application software or utility software, yes?
Yes. Yes.
And then the end user can use those particular softwares. This is
Yes,
what
ma'am.
is general categorization, right? So what are system software? System software help the computer hardware and system. They basically help run the computer hardware and system. Basically, they are an interpreter between the user and the hardware. That it is designed to control the operation of a computer and coordinate all external devices like communication devices, printer, keyboard, and all. It manages all computer resources like memory and processor time in optimal and stable manner. So the example is your operating system, right? So they actually the system software is the one which is running the computer hardware, right, or the computer system, and it is also an interface between the user and the hardware, and it provides you memory management, process management, file management, whatever are the features of the operating system it is providing. So the some common types of system software are operating systems, which is the software that manages all the computer resources to optimize its performance and provide common services for efficient execution of various application software and acts as an interpreter between the hardware and application program and the user. So that is the basic definition. So it is an essential part of any computer. Without you cannot communicate with the hardware. Operating system should be there. So what operating system perform basic tasks such as recognizing input from the keyboard, sending output to the display screen, keeping track of files and directories on the disk, and controlling peripheral devices. So basically there are features of operating system like your functions, process, it can do process management, memory management, file management, security, command interpretation. All these things can be done by the operating system. So when we talk about a process, anything which is running is a process. A program which is running in a run mode is a process. So all the programs which are running are processes in an operating system. So it manages all the processes, right? Then there are server programs. Server programs are dedicated computer programs that run as services and serve the needs or requests of other programs. These servers may run on a dedicated hardware or on the same computer requesting program. So you have web server, printer server, file server, database server, mail server. So these are also system software. Server programs are also what? System software. So web server software like Apache and all, printer software, file server, database server, mail server, these are also your what? System software, apart from operating system. Right. Then what else is there? System software, device drivers. Device drivers are also system software. Do you know what are device drivers?
Those support drives like CD drive and graphics card, all those drivers that support that.
The device
So
drivers
they
are
are
the
actually,
software, software, how do we say it?
yes, it
Which
is right.
helps the computer to recognize what it is.
Yeah, it is actually device drivers are programs, computer programs only. They are softwares only. That is an interface between the external devices and the hardware device, your hardware devices and the operating system.
It acts like a bridge.
Yeah, it acts like a bridge because how will the operating system understand which device is interacting with it? So device drivers are an interface between the hardware and the operating system. So they are also software programs. So you need device drivers for all the hardware which are attached on your system. Yes or no? So whenever you attach a particular device or hardware to your computer, so it tells you to install the device driver for that particular. Some of them are coming with plug and play, so you don't have to install it. But some devices require the installation of device driver. Yes.
Yes, ma'am.
So the device drivers are also what? They are also system software, right? And are dependent and operating system specific. They should be operating system specific. Do you know that? For Windows 10, you will have some device driver. For Windows 7, there will be some other device driver. Yes or no? So they are dependent on the operating system. Right. So what are the common hardware components that requires drivers are keyboard, mouse, printer, graphic card, sound card. These are the ones which require the CD, DVD drive, network cards and all that. These require a device driver, and device driver is also a system software. Then you also have communication softwares. What are communication softwares are also system software to interact with the network or in network environment. The communication software network operating system allows computers to communicate with each other. It enables sharing and transferring of data across the network. It controls network operations and manages network security. So communication softwares are also there. So these are your what? What are these? Communication software, device drivers, and operating system, and server program. These are your system software, which help to run your system, right? Then you have another second kind of type of software, programming software. Programming software are usually provide the tool to assist a programmer in writing computer programs. Naturally, you want to write computer programs, so you will require programming software. So programming software, like different programming languages are there. Those are programming software. Otherwise, also you have compilers, which we talked about right now, right? Compilers are there, debuggers are there. What are compilers we talked about? They convert high-level language into machine code, right? So compile is a program that it should be written compiler. A compiler is also a software. A compiler is a program that translates the code written in high-level programming language called the source code to the code in lower level language, that is the object code. Do you understand? Lower level means machine code or binary code. Right. So they convert a high level language code into machine code. The compiler translates each source code instruction into a set of rather than one object code instruction. So whole code is compiled by the compiler. So how does the compiler compile? Is the source code is given to the compiler. It converts according to its own. There are lexical analyzers, syntax, semantics. There is definition of compiler, and then it converts that code after it compiles to an object code, that is machine code. This is how a compiler works. What are debuggers? Do you know what are errors?
Yeah, something that stops a function from happening or
Yeah,
doing
errors
something.
are problems in the program or some software which stops it from working normally. So how to stop those errors is to debug those errors, to find out where the errors are. Do you understand? So you need to debug. Errors are known as in computers as bug. Do you understand? Bug means what?
Error.
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 Right. So bug in the sense like in our house some fly or some bug comes out, that also creates a problem in our house also, na? Like mosquito, right? So it bites. So we want that it should not come inside our house. Yes or no?
Yes, ma'am.
The same way we don't want that bugs or errors should come inside our program. So to find out what are the different bugs or errors in our program, we debug it. To find out the errors is debugging. So debugger or debugging tool is a computer program that is used to test and debug other programs, the target program. So a debugger is also a software which finds out the errors in a particular test target program. That what are the different errors or and it debugs it and finds out the different errors. So typically debuggers offer functions such as running a program step by step and single stepping, that means, or breaking the pausing the program to examine the current state, what is the value here and where is the problem coming, and whether you are able to trace the variable's value and it is coming or not, what value it is giving. So that kind of a thing. So you can find out the different errors, where the error is coming, you can find out through debuggers. So those are also your programming software, right? Then you have interpreters. Interpreter is another program which translates your high level language into machine code, same like a compiler, but it takes a source code instruction one at a time and translates and executes it. So one instruction at a time it executes it. So you give a source code, line by line it interprets and executes the result, right? That is a interpreter. You also have another software program, programming software, that is linker. Now what is the work of a linker is, like if somebody of some of you must have done some programming languages. So like if I talk about C or some C++, whatever programming language we talk about. So what happens is when your compiler interprets your program into machine code, that is object code, then you also have some library files in your in your program. Yes, you call some library files. You use some functions in those library files. I talked about reusable code na. So you have in your libraries you have certain functions which you have used in your program. So those library files have to be linked with the object code. Do you understand that? It has to be linked with your program code, the machine code. So those external libraries or library files which you have used, or the functions which you have used, those are linked with your object code, and then your result is executed. That is a linker. So the linker or link editor is a program that takes one or more object file code generated by a compiler and combines them into a single executable program. So basically what it is taking is, it is taking a object code of one and a library file object code also, and linking it and giving you the result. That is a linker. So in large software involving many programmers, then the modular approach is adapted. So you divide the program into modules or functions. So what happens is each module will be compiled separately. So to link all the modules in one program, one thing, so you link those through linker, right? So that is a linker. You also have another program software known as text editor. So text editor is a type of program used for editing plain text files, right? So there are different text editors also. No, Notepad is a text editor. Yes or no?
Yes.
TextPad, Notepad. So those where you can write plain text. There is no formatting. Not much formatting options are there, but you can
Sticky
write plain
notes.
text in that. So that these are also programming software. Then after programming software, the third type is application software. Now you know application software are specifically designed for a particular application. Like MS Word is designed for editing documents, right? PowerPoint is designed for making presentations. Excel is designed for financial or accounting or data for making charts and all that, right? Understand? So application software are for a specific task you want to solve. For that you make an application software. So that is also a programming software, and you could use it for commercial purposes, for scientific purposes, whatever. Different applications are made. So what are the different categories of your application programs? Are word processing software, spreadsheet software, database software, right? Right or wrong? So MS Word is an example of word processing software. Spreadsheet is MS Excel, where you can create any numeric based documents, right? Data analysis. Database softwares are also there to store and manipulate data, like MS Access is in Office and Oracle is there. SQL is there, presentation software is there, and PowerPoint. Graphic softwares are there, Photoshop, Illustrator. Multimedia authoring applications are there, like Mediator 9. So these are different application softwares, examples, right? So application softwares are also there for a specific purpose. They are used. So other application include like entertainment and education softwares are there, industrial, video games, telecommunication, mathematical software, right? So these are all application software, right? So these are there. So these are the different types of software. Then also another type of software is your utility software. I told you. The utility software are programs that help and manage and control the computer resources, which help to manage, maintain and control the computer resources. Like antivirus is a utility software. So what does it help you in? To find out the viruses in your computer. What is a virus?
Something that withstands from a function, which can corrupt your file, or which is malware, can harm your PC.
Yeah, can harm your PC. So computer viruses are also softwares that deliberately designed to interfere with computer operation, record, corrupt or delete data, right? They are also softwares. So to remove those viruses from your computer, what you have to do is you have to install an antivirus software. So this is a utility software. So they help you find out errors in your system and remove it. Right. So there are many antivirus software techniques which are there: signature-based detection, heuristic-based detection, file emulation. So there are different types of virus detection techniques, that how they detect the viruses. So it compares the contents of the infected file to a known pattern of data, because viruses has embed themselves in existing file. The entire file is searched. So what they do is they find out the signature of that particular virus, because they know that the pattern of data was this, but the infected file has this thing embedded inside it. So they find out that. Heuristic based detection is, this method is primarily used to identify unknown viruses by looking for malicious code or variations of such code. So heuristic based, what they will find out is they will find out any malicious code is there which is not good for the system. Then file emulation is there. This is another heuristic approach in which the infected program is run in a virtual environment and action it performs are recorded. So the actions are analyzed to check for any malicious actions and carry out disinfection actions accordingly. So file emulation is also another type of antivirus technique, where they will run that particular program or virus in a virtual environment, and they will record it, what it does, and then they will find out that how this virus can be disinfected or can be removed from the system. So these are the different things. So antivirus software can impair a computer's performance. Active antivirus program can cause conflicts with other programs. So what happens when you install an antivirus program? Sometimes what drawbacks comes is that it slows down your system. If somebody has antivirus in their system, sometimes what happens is it impairs the computer performance. Your system slows down. Do you understand? Or it may also interfere in some other programs also. Like suppose you want to have some file downloaded on your system, but it will not let you download that file. Why? Because it will say that it may harm your computer. It will not let you download. But it is not harmful, but still your computer, your antivirus will not let it do. So sometimes antivirus creates a problem also. And sometimes it is a false positive is when antivirus software identifies a non-malicious file as a virus. Like I'm telling you, I want to download that file. It is not virus prone, but it will not let me do it. So false positive it is. Do you understand? So I'm not able to download that particular file. It will delete that file if I download even, so that it will delete it. So most popular antivirus programs are not very effective against new viruses. So what happens is if I bought an antivirus program, so the new viruses which keep on erupting, sometimes that particular antivirus may not detect the new viruses because they are not upgraded to that level to find out the new viruses which are coming. So that is also a problem in the and some apparent antivirus program actually malware being sold as legitimate software. Sometimes what happens is you download a antivirus, but actually it is also a virus. That is also on the internet. Some certain free antiviruses are given, which are also another malware. And some commercial antivirus software agreements include a clause that subscription will be automatically renewed. For example, McAfee requires users to unsubscribe at least 60 days before the expiration of the present subscription. So sometimes what happens, they are saying that you have to, your subscription will be renewed automatically, but after that they will say that you have to pay this much and then your subscription will be renewed, something like that. So an antivirus generally runs at highly trusted kernel level of the operating system, creating a potential avenue of attack.
So can firewall be justified in case of antivirus? Can that be classified in antivirus?
That can be classified an antivirus, but it is not a full antivirus because it will not find out the errors and remove it. Right? It is firewall is generally used by when somebody who is a person who is want to access your system from outside.
So
So
if he's trying
antivirus,
to breach your computer,
so then it will stop it. But antivirus does the different thing.
so it's the
Anti
far most step it took.
hmm. Antivirus is if your system is infected or some files you are downloading or something you have done, and it will find out the errors and it will find out the malwares and remove it. That is what antivirus is. Then you have backup and utilities of backup utilities also. That is another utility software. Backup means you want to keep backup of your system, right?
Yes.
So there are different backup softwares which are there, like you keep backup in your CDs, hard drive and all that. Also certain programs are also nowadays providing, even system is also providing you backup facility. Your own software, your operating system is also providing that. So you have backup softwares also. Diagnostic programs are also there. What is diagnostic program? Suppose inside your system, your some hardware or some network or camera or this and that are not working. So what you do is you run these diagnostic programs so that they will find out what is the problem with the hardware device. Do you understand that?
Ma'am, that troubleshooting one.
A kind of troubleshooting, yes. So there are softwares for that. So there is your software diagnostic tools are power on self-test post. This isn't a separate diagnostic utility. It is in fact built into your system BIOS and it runs every time you start your PC automatically. So this is self power on self-test. This is another diagnostic tool. Mem.exe, this simple utility built into Windows operating system that provides you with details about your memory configuration as well as what is currently using your memory. These are being run automatically. You are not running it, but they are run automatically. Then Microsoft Diagnostic is there. This is small DOS utility that takes a brief inventory of the contents of your PC and shows them to you in a text-based format. So this is another one. Windows Device Manager is another one, right? Which shows you the system configuration. Norton system information is another diagnostic. Microsoft Scan Disk and Norton Disk Doctor. This will scan the disk for any viruses or something like that. Scan disk is there. What? If the disk is corrupted or in any form problem in the disk, so they will find out that. Then disk defragmenter is there, which fragments your files. How much is the used and how much is not used, that is there. Norton diagnostic is there. QA plus is there. So there are different diagnostics tools which are used for troubleshooting things. Right. Then file view programs are also there. File view programs like file viewer. In mobiles, you download sometimes a file viewer, but like in Microsoft, you have Explorer, right? Microsoft Explorer, which gives you the view of the files. So file views are also there, and even your editors are also file viewers. Yes or no? MS Word, Google Docs have also come as another online file viewer, right? So these are the other file viewer softwares which are there. Then computer performance enhancement utilities are also there. If this defragmenter, why do you use it? Suppose you have some files in your system. So what happens is it saves your files in any location. Your system finds wherever space, it saves the files in any location. So what happens is your files are not contiguous. Contiguous means not in one go the files are there which have been taken the space. So what happens in two files, some little spaces left blank, and then in three or four files, some little spaces left blank. So what happens? Suppose a new file you write it, so it is of more, it takes more memory. So that space in between the two files will not be taken by that particular file. So the system will make another location in the free. So what happens? The file is kept haywired way, and you are not able to get enough memory because your memory is stuck in between, small memory stuck in between the files. Do you understand that? Free memory. So that much file memory you are not getting. So what we do is we defragment the disk so that all the files which are taking memory are separate and all the free space is separate. Do you understand what I am talking about? So now the system will not look for a file where to put it. It will put it in the free space which is available. So that is defragmenter, and that is also one of the facilities which have been provided in your Windows. You also have cleanup facility offered, also disk cleanup. That is also another facility. Then do you know what are perverse software? Your malicious softwares are your perverse software. Do you understand that? Which cause hindrance in other programs. Your viruses, you can say, are your perverse software. So what are the different perverse software? We'll talk about that tomorrow. Right, for today we'll finish the class right now. So there are different perverse software or malicious software or viruses. So what are the different viruses and all that? We'll talk about that tomorrow. Right? Any doubt?
Okay, ma'am.
Any doubt anybody is having?
No, ma'am.
Yes, Vinay? Vinay, you have raised hand. You can unmute your mic. Vinay Bhardwaj. Has everybody put their name and enrollment number in the chat box?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Anybody is left?
No.
Okay, then we'll meet tomorrow. Right now your English class must be there, right?
Yes, ma'am.
Okay, I'm just taking your attendance, and tomorrow we'll meet.
Thank you, ma'am.
Welcome.